So the topic is formulas for rotation at the time of insertion. So we have already seen 4 rotations. We have seen upon only 3 nodes. If there are many nodes in a tree, then how rotation should be performed? So for that we will look at a formula. So I will show you only 2 formula, one for LL rotation, then LR rotation. Same thing applies for other 2. Let us look at first rotation. This is for LL rotation. I have taken an example tree. Only 3 nodes? No, it is having left child, right child. This is having right child, right child. Imagine a lot of nodes are there. So A is a root. No, imagine above that also a lot of elements are there. So where you are performing rotation? We are performing rotation upon this node who became imbalanced because balance factor is 2. Rotation is performed over this node. So we are talking about only 3 nodes. Maybe thousands of nodes are there in a tree. Imagine a lot of nodes are there in a tree. Alright. So now take it as a formula only with 3 nodes. If these are the balance factor, this is 2, this is 1, this is 0 means where the insertion is done, left, left. Right. If this is minus 1 means it is LR. Okay. This is LL. This is imbalance with the 2 means it is on left side. Then its left child is 1 means it is again on left side. If it is minus 1 means it's on right side. Okay, with this also you can observe. Now finally, let us see rotation. Which rotation we are going to perform? LL rotation. LL rotation around this node, upon this node. Then what is the result? Who will come here? B will come here. Where A will go? On the right side. Then who will come in the place of B? C. What about rest of the nodes? C is left child and right child as it is. A is right child as it is. A is right child. Now who is missing? B is right child. See, this is on the right hand side of B and B has become root. Already right side A is there. Then where this B should come? It will be on the right hand side of B only, but it will become a left child of A. And after rotation, we know that the balance factors, all of them become 0, 0. Yes, for those 3 nodes. That's it. This is like a formula. So how this is working, I'll show you. I said that this is a thread. Okay. So I'm keeping my finger here and pulling this thread. So if suppose something is attached to this thread like this. Okay. Something is attached to this thread like this, like this. So if I put a finger and pull it on this side, then this will stretch like this and this will reduce, right? Then what about that thing connected? It will come this side. It will come this side, right? So whatever was here on this side, it will come on that side. Same thing, this BR was on this side, just it's like a thread, pull it. So this will come this side. So the effect is just like rotation. So that's why people who have developed this one, they have given the name as rotation because the effect is just like rotation. Let us look at example of LL rotation and apply that formula. As an example, I have taken a bigger tree with around 9 nodes are there. Now let us give balance factor and check whether everything is balanced or not. Let us give the balance factor for leaves. This is 0, this is 0, this is also 0, this is also 0. Then let us move up. So this is 0, right? This one 0, 1, minus 1. This is 1, 2, 1, 2. So this is 0. This one 1, 2, 3, 1, 2, 1. 1, 2, 3, minus 2. So 1. And what about this 0 and 1? Minus 1. So this is balance. Now I will insert a new value that is 4. Insert 4. Key 4. Right? 4. 4 is smaller than 30. And also smaller than 20. Smaller than 10. Smaller than 5. So it comes here. So once it comes here, the balance factors along this path will update. So this is 0. What about this one now? This is 1, 0, 1. What about this one now? 1, 2 and 1. So this is 1. 2 minus 1, 1. What about this? 1, 2, 3 and 1, 2. So 3 minus 2 is 1. What about this? 1, 2, 3, 4, 1, 2. So this became 2. Yes, this node became imbalance. So here root node became imbalance, right? I selected the tree such that root becomes imbalance. Okay, now we can see it perfectly. Who became imbalance? This one. Where the insertion was done from here, check it. Left, 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 left. Shall I say LLLL 4 times? No. You have to consider only 3 nodes or 2 steps. So what are those steps? These. Only 3 nodes. L, L. After this point, wherever it is inserted, it is LL. See, this came on this side. If suppose this was not 4, I have inserted suppose 6. So it will come this side. Then also it is LL. We have to see from this node just 2 steps. That's all. Which rotation will perform? LL rotation only. So I will draw a rotated tree here. So the rotation will be performed around this node. So here, so 20 will move up. And the place of 20, 10 will come. At the place of 10, 5 and 4 all will move. 5, 4 all will move. And 30 will move this side. So 30 this side, 40 this side, 50 this side. Now what about right child of 10? 10 is there now. Right child remains on its own place. What about the right child of 20? 20 became new root now. So this subtree of 20 will go on this side here. So what is there? 25. And along with that, it is having right child. Keep it as it is. Don't disturb anything. Just instead of linking here, it is linking this side. Because 20 has become a new root. This is the tree. Let us check the balance factors. 0, 1, 0, 0. This is 0. This is 0, 1, minus 1. This one 0, 1, minus 1. What about this 1, 2 and 1? 1, 2 and 1. So this is 1. This is 1, 2, 1, 2, 0. This one 1, 2, 3. 1, 2, 3, 0. See the node over which we perform rotation, that should become 0. Right? So this is a balanced AVL tree. So I have given you an example without 4, then I have inserted 4, then it became imbalanced, then I have shown you how to use that LL rotation for balancing. So you must practice this one by yourself, watch it again, watch this video again and pause it and do it by yourself. Next I will show you LR rotation formula. This is an example tree which will work as a formula for LR rotation. So already we have 3 nodes and one of the node is imbalance. It is a positive means it is left side imbalance, right? Then this is negative means this is right side imbalance. So this is LR. Assume that something is inserted below C, right? Not just C, under that node C. As I said, rotation is done only among 3 nodes. So this became imbalanced, so we'll just see 3 nodes. Now LR rotation. This is double rotation. We know the direct method that C will move up and A will move on the right hand side. So I will show it like that only. So C is coming here, B in its own place, A will move on the right hand side. Okay, perfect. What about B's left child? B's left child will be as it is. What about A's right child? It will be as it is. Now the problem is with the children of C. This is on the left side of C, this is on the right hand side of C. So CL will remain on the left hand side of C, CR will remain on right hand side of C. This is how the children will get distributed. Watch again here, C's CL, CR. So C became root. So CL on this left subtree, here right here this side, and CR on that side. So I'll take one example and show you. Suppose this is a given tree. Check the balance factors. 0, 0, 0, 0. Then this is 1 and 0, 1. This is 1 minus 1, 0. This is 1, 2, 1, 2. So 0. This is 0 and 1 minus 1. 1, 2, 3. 1, 2, 1. So everything is perfect. It's a balanced AVL tree. Now let us insert a key 27. Key 27. Start from here, search for a location for 27, right? Search for 27. If not found, insert it. 27 is smaller, move this side. 27 is greater, move this side. 27 is smaller, move this side. 27 is greater, it's not there, so insert. When 27 is inserted here, now balance factors will update. This is 0, this is minus 1 because 0 minus 1 is minus 1. 1, 2 and this is 1, so this becomes 1. This 1, 2, 1, 2, 3. So 2 minus 3 becomes minus 1. And for this one, 1, 2, 3, 4, 1, 2. So this became imbalance. This node became imbalance. 2 is the balance factor, so the node became imbalanced. We have to perform rotation on that one. So which rotation we should perform? Check the direction of insertion. This is newly inserted node. Left, right, LR, LR. No. Just we have to check with the 3 nodes. It went on the left hand side and then right hand side. Right. See, this 27 went on the left side, then on right side, then below that where it has gone, we don't know. We are concerned about only these 3 nodes because this node became imbalanced. So from that point, just 3 nodes in the direction of insertion. So this is LR rotation. So we know the direct answer, so I will directly rotate this one. So 30 will go to 40 at the place of 40. 40 will move on the right hand side, and on the left hand side 20 remains as it is. So let us finish these extreme left 10 and 5 as it is. On that side we have 50 and 60, they are as it is, 50 and 60. Then 30 has become a new root. So what about 25 and 27? They remain on left hand side only. So 25 will be as a right child of this one, and its right child is 27. Then 35 will remain on the right hand side only, right subtree only. So this will become a left child of 40, 35. It will become a left child of previous root. So this is a balanced AVL tree. Let us check the balance factors and find out. 0, 0, 0, 0. This is 1 minus 0, 1. This is 0 minus 1, minus 1. This is 1, 2, 1, 2. 2 minus 2, 0. This is 0. This is 0 minus 1, minus 1. So this is 1 minus 2. So this is minus 1. This one, 1, 2, 3. Or you come this way also, 1, 2, 3. And 1, 2, 3. 3 minus 3, 0. It is balanced. So I have shown you formulas for LL and LR. RR and RL, I hope you have understood. So I don't have to show them. Alright. So that is a student exercise. So you prepare the formulas for them. You work out and prepare the formulas. So next we will take few keys and we will see how a AVL tree is generated. So that I'll explain you in the next video.